Hello. Alright, I will show us how to solve this question. The first thing I do, I draw a table. Now right here is my vertical component. And right here is my horizontal component. The next thing to do is to analyze the vector and to write out the different components for the vertical and horizontal. Our first vector here is 80 Newton. From the horizontal axis is 80 Newton at 65. In our vertical component is 80 sine 65 and for the horizontal it will be 80 cos 65. Okay, good. The next vector is 60 Newton. From the horizontal axis to my angle, that would give me 180. So this is 60 Newton at 180 degrees. So for the vertical component, it is 60 sine 180. For my horizontal, it will be 60 cos 180. Now the next vector is 100 Newton. 100 Newton from our positive x-axis to 100 Newton, that is 340. As you know, a circle is 360, so 360 minus 20 gives us 340. So it is 100 at 340. So it's 100 sine 340 and for the horizontal it will be 100 cos 340. Good. So now we can use our calculators to get the different values. So for 80 sine 65 gives us 72.5046 Newton. 80 cos 65 gives us 33.8095 Newton. 60 sine 180 is at 100 Newton. 60 cos 180 gives us negative 60 Newton. 100 sine 340 gives us negative 34.2020 Newton. And 100 cos 340 gives us 93.996 Newton. All right. So what we'll do next is to find the total vertical component. So my total vertical component is 38.8 38.3026 Newton, while my total horizontal component is 67.7788 Newton. All right, so this is the very first step. We get the values for the different components. Now we can now find the resultant and the duration. All right, so therefore my resultant is equal to the square root of the total vertical component squared plus the total horizontal component squared. All right, so this gives us my total vertical component is 38.3026 all squared plus my total component in the horizontal is 67.7788 all squared. Now if you punch this in your calculator, it should give us my R should be 77.9 Newton. So that is the magnitude of the vectors. Now I have to find the direction. So to find the direction, we use theta equal to tan inverse of V over H. The V is your total vertical components and your H is your total horizontal component. So we log in the data. Tan inverse is, my V is 38.3026 divided by my horizontal component, which is 67.7788. 67.7788. Now if you put this in your calculator, our theta should be equal to 29.5. degrees. Now to check if our angle falls within the positive horizontal axis, we draw a table. We draw a vector diagram using the values we got. So here is your positive y-axis, which becomes our vertical. Here is our negative y-axis, which becomes our negative v or negative vertical. Here is our positive vertical axis. Here is our negative x-axis, which can also be our negative total horizontal axis. While here is our positive x-axis, which can also be our positive horizontal axis. Now, the total horizontal axis is positive, so that means I have to draw a line to my right. If it was negative, I would draw it to my left. So because my total horizontal component is positive, from the origin, I would draw the line to my right. So here is my 67.7788 newtons. Now, for my vertical, if it is negative, I will draw it downwards from the nose of the first vector, but in this case, it is positive, so I will draw it up because the rule states that we draw the vector from the nose of the last vector. So from the last vector, I will draw my vertical component. Here is my vertical component, which is 38.7788 3026 Newton. Now the last thing we do here is to close the lines, drawing our vector from the origin to the nose of the last vector. So this is my resultant, which is 77.9, and right here is my angle, which is 29.5. Now, because the angle falls in this region, we will not subtract from 180. But if our angle falls outside this region, if our angle falls within this region, we have to subtract from 180. But because our angle falls within the positive or the first quadrant, we do not subtract from 180. So therefore my resultant is 77.9 Newton at 29.5 degrees. So that is our final answer.